Okay, pre-calculus, we are going to be doing, I guess this is the sixth, or the first day of Unit 6. I don't remember what day it is if you're counting Unit 5 days, but it's the first day of Unit 6. All right, so we're going to go over the law of sines today. So we have to review some things that we learned in geometry, and we're going to need a calculator. So you can either use the downloaded TI-84 Plus, or you can use Desmos.com. But just make sure you have the, well, I guess it doesn't really matter for you guys. I was going to say use the Virginia version, but all right, where am I? Okay, so to solve an oblique triangle, a triangle with no right angle, okay, you need to find the measures of all three sides and the measures of all three angles. That's just the definition. When someone asks you to solve a triangle, they want you to find all the missing angles and the missing sides. So to do so, you need to have specific information about the triangle before you start. So there are 5 different cases, okay, and we're going to do 3 of them today, and it might take more than 15 minutes. So in case 1, when you have side angle angle, and basically what this means is you have this angle is this angle is restricted, this angle is restricted, and this side is restricted. So back in geometry, when we were trying to prove triangles congruent, and I restricted 2 angles right next to each other, and the side that's called, we call it the non-included side, so it's on the excuse me, on the outside of the 2 angles. This was a way to prove triangles congruent, because no matter what we did, we couldn't get the triangles to be any different. Okay, so it really fixed that triangle. So let's look at the next way. The next way is angle side angle. Well, now we have the what's called the included side. The included side is in between those 2 angles. That also is a way to prove triangles congruent, and it really fixes those 2 triangles. So no matter what you do to the triangles, if you have 2 angles right next to each other and the side in between fixed, you're not changing that triangle. Shoot, did I just press pause? No, I didn't. Okay. So now the third way, though, we have angle side side. If you remember back from geometry, that was say we would say, okay, that makes a bad word, and that's not a way to prove triangles congruent. We kind of just stopped right there. But here's the reason, okay? So what happens is, I'm just going to make these bigger so maybe you can see them a little bit better. Just because we fix this angle, and we fix the length of this side and the length of this side, okay, we know nothing about the measure of this angle here, this C and this F, and then this side, nothing. So what happens is we could actually, if I show you the measure of this angle here that's on the other side of the second side, if I swing that side over here, I have a totally different triangle. So we actually have, we call this the ambiguous case. These 2 angles, we could have 2 different triangles, and this angle is a supplement of this angle. So we actually, when we're trying to figure out using the law of sines to solve a triangle, we have to check and see if there are 2 different triangles. And if we notice that there are, because it's possible to have 2 different triangles, and I'll show you how to do that in just a second, then we have to check and solve each of these triangles, because we don't know which one it is. But the others, we only have to solve for like 1 triangle. So those are the 3 cases we're going to learn today. Now, let me go back. Okay, so really, all we have to do is create a pair. If we have 1 angle and a side across from it, that is a pair. Because the other way, we're going to be writing a proportion. We won't know this side. Well, we can set up the proportion, make a ratio for this side using the law of sines, and then we can find that missing side. Here's another way. We know these 2 angles, so we could find the missing angle because we know the sum of all 3 of those angles has to add up to 180 degrees. Once we find that, then we have a pair, and then we can use one of the other angles to find a missing side. And same here, we already have a pair here, and we don't here, but we can make ourselves a ratio, a proportion. So in cases 4 and 5, and this is what we're going to learn tomorrow, we don't have a pair. we can't use what the law of sines, which is what you're going to learn in just a second. For case number 4 and case number, that should be a 5, because we don't know the measure of any of these angles, and we only know the lengths of the sides, and we don't know the measure of this side, so we can't create a pair with this angle. So those are being saved for tomorrow. Okay, and that's called the law of cosines. So here is the law of sines. Okay, so basically what the law of sines says is we can take the sine of, and all the angles are in capital letters and all the sides across from them are the same lowercase letter. We can take the sine of this angle over the measure of the side opposite, and that's the same ratio as if we took the sine of this angle B and the side across from it. Because notice, the bigger you make the angle, the side across from it is even bigger. The smaller you make the angle, here's a small angle, the side across from it is also very small. And those are things that you learned back in geometry as well. So you can put, it doesn't really matter if you put the A over the sine of A, the B over sine of B. You just have to be consistent. If you're going to make a proportion where you put the sine of A over, let's say, the sine of A over A and the sine of B over B, that's fine. Unless if you want to put B over the sine of B, that's fine too. But then you have to put C over the sine of C, or whichever two you are deciding to choose for your proportion. Let's do an example. So example 1, use the law of sines to solve an SAA triangle. Now, I usually, when I do these problems, I don't think, okay, this is SAA. I don't go into them yet. I look to see if I can find a pair. If I can find a pair, I use the law of sines because it is much easier than using the law of cosines, which you'll see next class. So the first thing I'm going to do is look for a pair here. Okay, see this 40 degrees and this side across from it is a 4? We have the measure of this angle A, and we have the measure of the side across from it. Okay, so right there, I can make myself one side of my proportion, and it's right here for both of these. See there? I wrote there. And I decided to put 4 over the sine of 40. Okay, now it's easier, whatever you're solving for, to put that in the numerator, but it doesn't really matter. Okay, so I've got my pair here, and I just decided, first thing I'm going to do is I'm going to solve what is the measure of this missing angle here. I've got 60, I've got 40. Well, 60 plus 40 is 100. So if I subtract those two from 180, the measure of the missing angle is going to be 80, because all three of them have to add up to 180. Now that I've got the measure of angle C is 80 degrees, it doesn't really matter where I start, but I'm going to start with my pair here. 4 over the sine of 40 equals, and I just decided I was going to solve for side B first because I don't know what it is, so we'll just go ahead and start there. So this is my other side. So since I'm solving for side B, I'm going to put B over here, and the side that's opposite it is angle, or the angle opposite is angle B. So I'm going to put the sine of 60 degrees here. Now we're working in degrees, so you want to make sure whichever calculator you choose to use, whether it's Desmos or the TI-84 app or an actual TI-84, that your calculator is in degree mode. So we'll get there in just a second. So if you cross multiply, and I'm not going to write all this out because I am assuming that you guys know how to solve a proportion at this point, okay? But if you cross multiply, okay, you're going to get 4 times the sine of 60 equals B times the sine of 40, right? Then you're going to solve for B. So you're going to divide both sides by the sine of 40. So you're going to end up with B equals whatever 4 times the sine of 60 degrees over the sine of 40 is. Okay, so on the TI-84, first you have to go to mode and you have to change it to degrees. I've already done that. So you would scroll down to the right and then you would press enter. Okay, once it's been highlighted and it's good to go, you can go second quit. So this is 4 times the sine of, 60 degrees. And we're multiplying, so we don't have to worry about parentheses, divided by the sine of 40. And if your calculator is in degrees, you should get 5.389. If your calculator is in radians, you will get some weird, funky, like -1 point something, and then you know you made a mistake. If you choose to use the Desmos calculator, it'll look like this, and it's already going to be in degrees. All right, so go back here. All right, so we got B, the length of B is approximately 5.389. Now, if you have rounded a number, you really don't want to use a rounded number in another calculation. You'll see that a lot in like physics, where if you use a rounded number and then you use it in another calculation and then you round that value and you use it in your final answer is going to be so off. So it's better to use this 4 over sine of 40 again, even though now that I have B, I could use the sine of 60 over B, which is 5.389. But again, I'm using a rounded number, so I'm going to choose not to do that unless I absolutely have to. So to find C, C is across from the 80 degrees, so that's the sine of 80 degrees. When I cross multiply and divide, I get C is equal to the 4 times the sine of 80 degrees over the sine of 40 degrees, and so C is approximately 6.128. Now I've got all the measures of the sides and all the measures of the angles, and let's make sure there I solve for B, I solve for C, and we also solve for the measure of angle C. So those are your 3 answers, and we are done with that problem. Moving on. Okay, so now we've got an angle, side angle, okay, and that's not really too important. What's important here is that I can, if I know the measures of these angles, 35 and 15, we know the measure of angle C is 130 degrees. Once we have the measure of C, hold on just a second. Now we can go ahead, okay, so now we can go ahead and we have a pair. So I'm going to use that in both when I'm trying to find side A and side B, just because they're not rounded. All right, so 5 over the sine of 130 equals, now I just decided I'm going to solve for side A first, okay, over the measure of side A over the sine of the angle across from it, angle A, is 35 degrees. So I cross multiply and divide, and I get A is approximately 3.744. Okay, I'm going to do that for side B as well. And I'm going to put B over, what's across from B? 15 degrees. Sine of 15 degrees. Cross multiply, divide. B is approximately 1.689. Now, do this. Make sure you can actually do this on your calculator and you're getting these values, because you need to be able to do that. Okay, if you've got time, pause, try this problem, and check the answers and see how you did. We're going to move on to the ambiguous case. Now, I left this explanation of the ambiguous case in the notes here, but I think the best way to explain this is to take a look at Gizmos. Okay, I'm confused. Where is it? Here. Okay, so I'm going to show you this triangle again. I better get a decent one. Okay, just because this angle has been fixed and the side next to it and the side next to that has been fixed, we don't know anything about this angle. So that's the measure of this third side. So we're going to have to check that. I'm going to leave that for just a second. First, I'm going to show you that these two angles are supplementary, and then I'm going to show you how that leads into our next problem. Okay, so these two angles here are supplementary. All right, let me pause this. All right, so I go, all right, am I going to be using the law of sines? Well, I've got a pair, so I'm going to go ahead and start using the law of sines. So I wrote sine of 40 degrees over 3 equals, and I just decided I would solve for angle C, because notice, angle, here's the angle that we know, here's the side, and here's the side. There's ASS. So this angle, C, is the one that could be whatever we solve for, or its supplement. So, let me back up. And I'm going to go ahead and solve for it. So, we got the sine of C, which we don't know, right? Over 2 is the length of C. Cross multiply and divide, you're going to get the sine of C equals 2 times the sine of 40 degrees over 3. Now we have to, hopefully you remember how to do this, I taught you earlier in the year, but also in geometry, we take the inverse sine of sine and we're going to undo it, right? As the inverse operation. So if I take the inverse sine of this entire side, I'm going to get